Okay, I hope all is going well. Just wanted to give you a philosophy explanation of what we're about to do. This is something that kids have never seen before. That's one huge downside of having e-learning this time of year is we are dealing with the most difficult material, so it will be a little more difficult for kids. Hopefully no one is skipping these videos because these videos are key to understanding what to do. We've got three different types of problems. This is a problem that they have seen for years, where it's an x to the first, even though there's more than one term. We have what we did Wednesday, where we have an x squared, but there's still only one term. Today, we're going to have an x squared and an x type. Like in my example here, x squared plus 5x. We will talk about that, and that's what we're going to be doing on the assignment. First, let's go back to this one. This is what they've always been doing, and the strategy is get the variable on one side, get the numbers on the other. So what they've always done in this problem is they combine like terms on this side, get 7x plus 9 equals 23, and then keep x over here and take the numbers to the other side. This is what students have been doing. And then now that we have the x isolated, we can get rid of the 7 and get x equals 2. So the philosophy has been get x's on one side, get numbers on the other side, and then usually your last step is divide. That still worked on this kind of x squared problem. We have an x squared right here, so we're trying to get all the numbers to the other side. To do that, we subtracted 10 Wednesday. That left me with 5x squared equals 8. Then we divided both sides by 5 and got x squared equals 8 over 5. And then we did the opposite of squaring, which is square rooting. Many of you did not follow directions or watch the video. In this situation, I wanted you to first go ahead and divide 8 by 5. And that gives you 1.6. X squared equals 1.6. And then take the square root of 1.6. The square root of 1.6 is, and you were supposed to round it to 3 decimals, 264, so the 9 says bump it to a 5. So your answer was, remember, plus or minus 1.265. Okay, 1.265. Reminder, some of you have the fancy calculators that try to simplify the radical, which is fine. That's actually what you'll do more in upper level math. We just haven't talked about how to simplify a radical yet. You need to click the SD button, and that'll click it or switch it from a simplified radical to a decimal so that you can round it to 1.765 or 1.265 in this example. Okay? But this can still be done the same way, where you try to get x on one side and move all the numbers to the other side. Okay? You can still do these kind like the x to the first because you can isolate the variable term. I can get 5x squared by itself and solve for x. In this kind, you cannot. You cannot solve these like the others because you cannot combine a 5x squared and a 5x into one term. Instead of moving the 20 over here and trying to combine these, which you cannot because they're not like terms, we're going to need to do a totally different philosophy on this problem. I will go ahead and work this problem, but I've got examples coming up in a moment. What we want to do instead of getting the numbers on one side, variables on the other, is we want everything on one side. I'm actually going to move the 6 over here with the 20 by adding 6. And the reason why we do this is we're trying to create a 0 over here. Okay? We want a 0 on this side. Now the philosophy here is we don't know what adds to get 0. There's lots of different things that can add to get 0, add or subtract to get 0. What we want is things that multiply to get 0. Again, this is on your notes. You don't have to panic right now. Right now you should just be listening. You don't have to worry about writing this down. It will be provided for you in the notes. We want to switch this from an adding and subtracting problem to a multiplication problem. Because what multiplies to get 0? Well, we know that either one of these guys can be 0. So multiplication to get 0 is important to us in this kind of problem. And the way we'd switch this is what we've been doing for the last month. We switch an adding and subtracting problem to a multiplication problem by factoring. This is a trinomial math game, so it's going to factor into two binomials with an x and an x. What multiplies to get 14, but we'll add or subtract 5. It's x plus 7, x minus 2. Okay, so we get everything on one side. Again, these are in your notes. You're going to factor using one of our methods. This is a trinomial easy math game type. And now that I know that I have something times something equals 0, what the notes will tell you to do is set the first one equal to 0, set the second one equal to 0, and then solve. This answer is -7. This answer is +2. That's another thing I want to mention that I think, can't remember if I did Wednesday or not. Anytime you have an x squared equation, that means you're going to get two answers to the problem. In an x to the first, it meant you were going to get one answer. In an x squared, it meant you were going to get two answers, in this case positive and negative something. Well, in this case, you're going to get two answers, but they're going to be unrelated. This one's going to be a -7. This one's going to be a +2. Okay? So this was more about the philosophy. X to the first, you can combine like terms, isolate, divide, and get an answer. X squared only, you could still isolate the x squared by moving the 10, dividing, taking the square root of both sides, and getting the answer. In an x squared with an x, you cannot do it the same way. You have to get everything on one side, 0 on the other. Use the factoring concept that we've been doing, and then solve. Okay? Sorry this video went a little long, but it was important. In a moment there will be a video with some examples.